Okay, so I want to try to teach you about capacitors. And if you look at problem 1, you have a 500 volt battery. Now when I draw a battery, I want a long for the positive terminal and a short for the negative. And then I come up here and I draw two lines that are supposed to be the same length. And actually the one that's in your problem, I need to draw it so I don't confuse you. So here's a capacitor, and then here's another capacitor. And this one is capacitor 1, and it's 2 microfarads. And capacitor 2 is equal to 3 microfarads. Now, if I think about this positive charge flowing, it collects on that plate, and as a result, it attracts an equal amount of negative that came from that plate. This plate then has 2 or how many ever charges that are sitting by themselves, which causes the electrons to flow in that direction. So positives go that way, electrons go that way. So if that is true, whatever charge is here has to be equal but opposite to this charge here, which is equal to opposite but this charge here, which is equal to opposite to this charge here. So Q1 and Q2 have to equal each other, and they're equal to the total charge available from the battery. And the voltage on 1 plus the voltage on 2 equals the voltage total. And I say that these two capacitors are in series because there is only one pathway, just like it was with circuits. And these are very similar to circuits. The big difference is, though, these charges just stack up and they stay there ready to be used as energy whenever they're needed. Okay? So the only different thing with this one is that instead of the capacitors adding up like they did in the series circuit where you added up the resistors, these are going to be the reciprocals. 1 over C1 plus 1 over C2 equals 1 over C total. So I'm going to say 1 over 2 plus 1 over 3. Now these are microfarads, so my answer is going to come out in microfarads. I'm just not going to write them down because I don't need to worry with the 10 to the minus 6 since it's not going to change when I do the math. So I say 1 over 2 plus 1 over 3. Well, I don't have a calculator here, so I'm going to have to do this by hand. So I'm going to say, well, that's 3/6 plus 2/6 equals 1 over CT. So CT is going to be 5 over 6 is equal to 1 over CT. So if I flip it over, 6 over 5 is equal to CT over 1, or 1.2 microfarads is my total capacitance. And remember, I used this microfarad because both of them were microfarads, and I just didn't put it in the math until the end because it just kept the math simple. So there's CT. Well, QT, Q total, is C total, V total. So C total is 1.2 microfarads. V total was 500 volts. So the total charge is 600 microcoulombs. Q1 is 600 microcoulombs, and Q2 is 600 microcoulombs. Because if you go back and look at that picture, whatever amount of charge was negative over here, I had an equal amount here, an equal amount there, and an equal amount positive. So there's C1, C2, and C total. Alright, so V1 is going to be Q1 over C1. So that's 600 microfarads over that's 600 microcoulombs over 2 microfarads. So the micros will cancel. So V1 is 300 volts. V2 is 500 minus 300, because 500 is the total, and I used 300 on the first one. So V2 is 200 microvolt, or 200 volts. If I don't want to do it that way, I can say V2 is equal to Q2 over C2, and I'll get 600 microcoulombs over 3 microfarads. The micros will cancel, and I'll get 200 volts. Alright, now they want me to talk about the energy. Well, energy is very easy. Energy 1 is just 1/2 the capacitance times the voltage squared. So that's going to be 1/2 times 2 microfarads times 300 volts. Don't forget to square it. So when I square 300, I get 9 followed by 4 zeros, 90,000 volts. And I'm going to multiply that by 1/2 of 2 is 1. So energy is going to be 90,000. I haven't changed anything with the micro, so it has to stay. Joules, 90,000 microjoules. If you don't want to write it that way, you can say that it is 0.09 joules. Either one is the same thing. I just leave it in micro because then I don't have to mess with moving the decimal. E2 is 1/2 C2 V2 squared. So that's 1/2. C2 was 3 microfarads, and V2 was 200 volts squared. So 200 squared is 4 followed by 4 zeros. 1/2 of 3 is 1.5. So I can multiply 1.5 times 40,000 and I'll get 60,000 microjoules, or 0.06 joules. And then I think they want E total. So E total is going to be E1 plus E2, but I can also do 1/2 C total V total squared and check myself, because I don't have a calculator with me. I'm just doing all this in my head. C total was 1.2 microfarads, and V total was 500. Now don't forget to square it. So that's 25 followed by 4 zeros. So that's 250,000 volts squared. And 1/2 of 1.2 is 0.6. And so if I multiply 0.6 times 250,000, I think I'm going to get 150,000 microjoules for my E total. So there's number 1. Number 2 is a little bit different because they're in parallel. Oop, I just tried to draw a resistor, sorry. So there's my capacitor. And my battery is right here. And this is a 5 picofarad for C1. And C2 is 10 picofarad. Now a picofarad is 10 to the minus 9. No, 10 to the minus 12, sorry, 10 to the minus 12. My voltage is 1,000. So in a parallel with capacitors, the voltage total is equal to V1 is equal to V2, just like it was in the resistors that we talked about last week. The capacitance total is just C1 plus C2. So that's the opposite of what we did with parallels last in the resistors. We had to do 1 over, 1 over. And then Q total is equal to Q1 plus Q2, just as the total current was equal to I1 plus I2 with the parallels. All right, so C total for this one is going to be 10 and 5 is 15 picofarads. V1, V2, and V total are 1,000. Q1 is going to be C1 over V1. So that's going to be 5 picofarads. I'm sorry, you know what? That's not a good formula. How about if we did this? Q is equal to C1 V1. There we go. So 5 picofarads times 1,000 volts is 5,000 picocoulombs. And I'm going to leave it just like that. Q2 is going to be C2 V2. So that's 10 picofarads times 1,000 volts. So Q2 is going to be 10,000 picocoulombs. And then Q total is the sum of those two, 15,000. But I can also do C total, V total. So total capacitance was 15 picofarads. Can multiply that by 1,000 volts. So that's going to be 15,000 picocoulombs. So we're done there.